I'm going to be talking about solving equations and then absolute values. An equation is just two mathematical expressions being set equal to each other. For example, 2x plus 3 is equal to 15. What it means to solve an equation like this is to isolate x on one side of the equation so that there are no operations on it. This will give you the value of x that when plugged into the original equation will cause equality to hold. If we look at this equation, first x is being multiplied by 2, and then 3 is being added to that product by order of operations. To isolate x, we must simply apply the opposite operation on both sides of the equation, and do so in the opposite order that the operations were originally applied. Since the last thing we do to x is add 3, we want to subtract 3 from both sides of the equation. If we do this, we get 2x plus 3 minus 3 is equal to 15 minus 3. These 3's will cancel, and we're left with 2x is equal to 12. Now let's get rid of the times 2 operation by dividing both sides by 2. If we do that, we'll have 2x over 2 equals 12 over 2. These 2's will cancel, and x is equal to 12 over 2, which is 6. Now if we plug 6 back in this equation, 2 times 6 plus 3 is equal to 12 plus 3, which is equal to 15, just like the equation asked. In general, you can perform any operation to both sides of an equation, such as addition, multiplication, subtraction, or division, and both sides will still be equal. Next, let's talk about absolute values. For any real number x, the absolute value of x is equal to x if x is 0 or positive, and it's equal to minus x if x is negative. For example, absolute value of 3 is equal to 3, since 3 is positive. Absolute value of 0 is equal to 0, since it's 0. And absolute value of minus 7 is equal to 7, since 7 is negative, and minus 7 equals 7. Essentially, what the absolute value does is it removes any minus signs from your expression. Now notice how the notation for taking the absolute value of an expression is enclosing it with these vertical bars, like this. So we have 2x minus 5. This notation means that everything within these bars has the absolute value taken of it. So if x was large enough that 2x minus 5 was positive, this expression would be equal to 2x minus 5. In fact, the absolute value sign works sort of like parentheses do. We can write this as 2x minus 5 in parentheses and have the absolute value taken of that, and it'll mean the same thing. This means in order of operations, the absolute value is taken at the same time an expression is evaluated inside of parentheses. Let's consider an equation that has an absolute value in it. What if we had x minus 2 is equal to 3, but with an absolute value around x minus 2? To solve this, we want to split it into two cases. One of them when we have x minus 2 equals 3, and the other one when we have minus x minus 2 equals 3. Since these are the two possible values absolute value of x minus 2 can take. We can solve the left equation by adding 2 to both sides to get x equals 3 plus 2 equals 5, and the right equation says minus x plus 2 is equal to 3. If we subtract 2 from both sides, this says minus x equals 3 minus 2 equals 1, and finally multiplying both sides by minus 1 will give us x equals minus 1. These two, x equals 5 and x equals minus 1, are both possible answers to this equation. However, x minus 2 is not always the same as the absolute value of x minus 2, so 5 might not be a solution. And similarly, minus x minus 2 is not always the same as absolute value of x minus 2, so x equals minus 1 could also potentially not be a solution. When solving any equation like this, we need to split it up into two cases and then check to make sure that our final answers will work. So if we plug 5 into this equation, we have absolute value 5 minus 2 equals 3. 5 minus 2 is 3, and absolute value of 3 is equal to 3. So 5 is a good solution. Now in the other case, at x equals minus 1, we have absolute value of minus 1 minus 2 equals 3. Minus 1 minus 2 is minus 3. So this is equivalent to saying absolute value of minus 3 equals 3. This is also true. So 5 and minus 1 are indeed solutions. Note also that if we change this equation slightly and instead have absolute value x minus 2 equals minus 3, this equation will have no solution. This is because absolute value of x minus 2 must be greater than or equal to 0, but minus 3 is not, so they can't ever be equal. If we had actually split this up into two cases and solved for each one, we would have realized when checking our answers that neither of them would work.